I welcome you on Lesson 2. In this video lesson we are going to speak about static routing and different types of the static routing. First of all, we have to take a look what is the purpose of the static routing. And we have the small topology which shows us some networks, like we have network 1, 2, 3, 4, 5, 6 and 7. So in this topology we have 7 networks. And if you will try to take a look for the routing table of router 1 after you have configured all interfaces of router 1 like gigabit 0, 0, 0, 1 and 0, 2, you will see in your table only 3 networks which are directly connected to this router. And there is no information about other networks which are not directly connected. Like network 10.0.0.4 is not in the routing table, and this network, and also this network. It means that router 1 will be able to make communication and will be able to make a routing only and only between 3 networks. Network 10.0, 20.0, and 10.0.0.0 with prefix 30. So to be able to make communication with other networks which are not directly connected with the router 1, we will use with you a static routing. So we have with you different types of static routing. Directly connected static routing. What does it mean and how to make configuration of it? First of all, let's take a look for the idea of the configuring of the static routing. So when you are configuring static routing, you are saying to router 1 that router 1 has connectivity to this network. Afterwards, you say, all right, you have connectivity to also this network, and you have connectivity to this network, and also you have connectivity with this network 811 and 110. So, and each of these arrows which I drew here will require to have a separate row of the configuration of the static routing in router 1. How to make the configuration of directly connected static routing. So you need to go to global configuration mode of router 1, and from global configuration mode you have to just say to your router 1 that it has connectivity, for example about with network 10. So you are writing this command IP route, then you define network address 172.168.1.0. Afterward, you define the subnet mask of this prefix. This 255.255.255 and 0. And afterward, you are defining exit interface. So here it is. So your router 1 will exit through gigabit 00 interface to have connectivity to network 172.168.1 and 0. So that you are writing here gigabit 0 and 0. Okay, let's try to do it. So it's actually the command of the directly connected static routing. Now we'll penetrate into configuration of router 1, and in global configuration mode. But first of all, let's take a look for routing table. And in this routing table, we may see with you 3 directly connected networks, and let me even do it in this way. I want to see only connected networks, so here are they. Okay, and now I need to provide information about that network. So let's place it on top. And let's provide this configuration to our router. Alright, so we are writing in global configuration mode IP route 172.168.1.0 with subnet mask of prefix 24. Afterward, we are defining this interface, which is the exit interface for that network. Then we'll check our routing table. We'll write command show IP route, and here it is. Here you may find out S value, I mean S code. S code defines that this is a static routing which being configured manually. And the network with prefix 24 is directly connected is directly connected by gigabit 00 interface, but actually it is not directly connected. It is statically configured, but the type of the static routing is called directly connected, and router think that it is connected right with the gigabit 00 interface. It's time to make also configuration from router 2 to this network, because if you'll take a look with you for this topology, in case if you configured your router 1 with that network, but you didn't configure router 2, so then router 2 will receive the packet. So look, we are making to make communication from PC2 to PC4, and when our router 1 will resend this packet to router 2, router 2, if it doesn't know about existence of this network, and it doesn't know about existence of that network because router 1 knows only about this network and this network, in case if we didn't configure any static or dynamic routing. And then router 2 also have to know about that network, and you have to write absolutely same command from router 2 to that network, but only the difference is the exit interface. So the exit interface in this example will be a router's interface S0, 0, and 0. So let's open router 2 now, and we'll make configuration of its static route. So we'll write IP route 172.168 and 0 with subnet mask of prefix 24, and exit interface of router 2 is S0, 0, 0. So let me save my configurations. Let me type command show IP route, and here I can find now the path to the network 172.168 and 0, which will be exiting from the serial 0, 0, and 0 interface. Now let me show you what will be happening if you will try to make ping from PC2 to PC4. We'll open simulation mode, and in simulation mode we'll click the button show all or none. Okay, so we need to clear all the filters of the protocols, and we'll just select with you ARP and ICMP, which are responsible. ARP is responsible for finding out the MAC address of the by the IP address, and ICMP is responsible to make the ping. So source and destination, and now I'm trying to make ping. So packet, ICMP packet goes to switch, switch sends to router 1. Router 1 is resending information to router 2 because it knows that this network 10 is connected through gigabit 00 interface, and now router 2 also knows about it, and router 2 resend it to router 3. Router 3 directly connected to that network, so that is why we don't need to provide the static routing for router 3. And information goes to PC4, and from PC4 we have an answer. So answer will go to switch, and switch will resend to router 3, but afterward router will do what? Will delete this ICMP response and will send an ICMP reply from itself. So, and in this reply will be information like destination host unreachable, and then our ping will not be successful. What is the reason for that? The reason for that, router 3 doesn't know about network 192.168.190, and when our communication goes by using this way, computer sends reply to IP address 192.168.10 and 2 with prefix 24, and when this reply goes to router, and routing table of router 3 knows only about this network, this network, this network, and this network, so that router 3 have to be provided with proper information about this network. So you have to write the command on router 3 like IP route, and you have to define 192.168 what is there, 10 and 0 with subnet mask of prefix 24, and with exit interface S0, 0, and 0, S0, 0, and 0. Then router 3 will be able to resend it to router 2. But when this information will come to router 2, in router 2's routing table, we don't have information about this network because it is not directly connected. That is why you have to also provide this information, this configuration to router 2. You'll write IP route 192.168.10.0 with subnet mask, and only you will change the interface. Exit interface is going to be gigabit 00 because your router will resend this information right from this interface. Then only after these configurations you will be able to communicate from PC2 to PC4. So let's try to do it. Now we'll finish this communication. We'll say delete, and we'll go to the real-time mode, and we'll check the routing table of router 3 before we'll start to make configuration of the static routing. And show IP route, and it's not showing us that we have information with this communication with this network 192.168.10.0. So that is why we'll just provide this information manually by using command show IP route 192.168.10.0 with subnet mask of prefix 24, and with exit interface, so our router will exit through its interface S000. S000. Now we'll write command show IP route, and we are able to find out here a statically configured route to network 10.0. And let's try to make ping one more time. It will be not successfully, but we'll see in which step we will have issue. So it can go here. Now router 3 will be able to resend it to router 2, but now router 2 will make response like I don't have this network in my routing table. So let's take a look for the routing table of router 2, in which we will see information only. We have static routing to network 172.1.6, this network, but we don't have configuration of static routing to this network. So that is why we have to go to global configuration mode, and as we did before, we have to just provide this information about network 10.0 with subnet mask of prefix 24. With exit interface from router 2, it's going to be gigabit 00. Gigabit 00. And now we'll take a look for our routing table, and we can see this network, which is exiting through gigabit 00 interface. Now I'll delete this communication, and I'll try to make communication one more time. And router, where's that? Router 3 will resend this information to router 2, and router 2 will send an ARP because router 2 doesn't know about MAC address of this neighboring IP address. It's okay, so that after our router will learn about it, we'll try to make ping one more time. Here we go. Here it is. And only after what we have our proper communication between two devices which are placed on different networks. You can also check it with this ping command 1 and, or maybe it was 10, no, 1 and 10, and you see that reply is successfully coming to you. So we have sent 4 packages and 4 of them being delivered, and we have 0% of lost. This is how we can make configuration of static routing which is directly connected. And now I will show you what is the differences, what are the differences between directly connected static routing and recursive static routing. So let me place tick. We finished it. Now let's take a look for recursive static routing. So first of all, I will write again this command. IP route, and we had network with you like this, or even let me say 172.168.16.10 with subnet mask like this, and exit interface being gigabit 00 if it is configuration from router 1. Now it was configuration of directly connected static routing. what are the differences between a recursive static routing? So you can do the same, but something will be different. So let me show you what will be different in the configuration. The same subnet mask, and instead of writing exit interface, you will just write the next hop IP address. So yeah, let me go back. And here, when we are representing to router 1 information about this network, we will say you will not exit from this interface, but you will go to this IP address. And this IP address is 10, 0, 0, and 2. Okay, so it is called next hop IP address. So that here I will write 10, 0, 0, 2. Then if you will configure your route by using this command, you will have recursive static routing. Why it is called recursive static routing, we will see with you from the exit, from the output of the routing table. So that let's first of all try to do it, and afterward we'll take a look for the routing table and make decision why it is called recursive static routing. First of all, let me delete my previous configuration of static route to this network, and I will write the command like no IP route 172.168.1.16.1.0 with subnet mask of prefix 24 and exit interface being like this. Do show IP route. So I'm checking, did I delete this static route? Yes, it seems like I did it. And now let me make configuration of my new static route. So I'll just take off this no command. And here I will just write the next hop IP address is going to be 10.0.0.2. So it's IP address of my neighbor. So let me show you this neighbor's IP address. And here it is. From router 1 to network 172.1.6.1.0, next hop IP address is 10.0.0.2. I'm just defining it. Now it is ready, and I will show you what is going to be value in your routing table. Show IP route. Now you have a statically configured network which has this value, this administrative distance 1. It means that this network is statically configured and your router knows about it. And here you can see via, it is like through this IP address. So network 172.1.6.1.0 is configured through this IP address. Now, when your router make a lookup, it means that when router receives the packet, it has to find where to resend the packet. And when the router looks for the routing table, and it will find the destination network like this, which is not directly connected, which is connected via this IP address. But there is no information through which interface it will exit. Then router, so look, our first lookup, so even let me do it in this way. I'll just paste the new slide here. And when our router will make first lookup, it will, so look, first lookup will be blue lookup. Our router will find, alright, this network, okay. And afterward, our router will find out that through this IP address. And then, next step, router 1 have to make research. How can I find the exit interface? And second lookup will be done like this. So, directly connected network, like this, okay. It is connected through gigabit 00 interface, and I can send information to this IP address, because it is part of this network through gigabit 00 interface. So you make one job to do another job. After we completed the recursive static routing, it's time to speak about summary route. What is the summary route and what are advantages of using summary route? Let's take a look for an example where we have router 1 that is connecting remotely to networks 172.168.1.0 and 2.0. And we have to make static routing for both of these networks, so that we have to write in router 1 commands like IP route 172.168.1.0 with subnet mask of prefix 24. And afterward we may select directly connected static routing or recursive static routing. For example, we are selecting directly connected static routing. Next, we have to write command IP route 172.168.1.20 with the subnet mask of prefix 24 and gigabit 00. So when you will type these two commands, you will see in your routing table two values like statically configured network 172.168.1.0 and statically configured 172.168.2.0, which are directly connected like this and like this interfaces. So if you have a lot of networks, so then you will have a lot of commands and you will have a lot of values in the routing table. In case if your routing table is very huge, then it is not so good for your router, because your router will make search for the destination network address in routing table, and if you have a lot of data inside this routing table, then your router will work more time than if it is going to be the small table. And also you have to type a lot of commands, and to prevent the situation, you are able to take the summary, the common part of that network, of those networks. Like we have two networks, 172.168.1.0 and prefix 24, and 172.168.2.0 with prefix 24. So we may take a common part of this of these two networks, and then we can just write only single command. How to make a summary? How to find the common part? We can just say, all right, this part is common on both of these two networks, but we can take more bits which are in common, so that if you will open third octet in your IP version 4 addresses, then you will find it. 172.168, and let me just write 1 in the binary stream, 1 2 3 4 5 6 7 8, and 172.168.1 1 2 3 4 5 6 7 8. Oh, this is 2 in binary. Here we have zeros and zeros. Now we are able to take the common bits up to this line, because after this line we have differences 0 1 and 1 0 and so on, so that our common IP address and our common network address will be 172.168. So this part will be 0 and 0, and then we have to calculate what is going to be our prefix. Our prefix being 24, but now it is 2 bits less, and it's going to be prefix of 22. So that when you will try to make configuration of your static route to this network, summary network, then you also have to find what is going to be the subnet mask of this prefix. To find it out, you have to look for 22 bits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And after we'll convert them, these bits, we'll have 255, we'll have 255, and we'll have 255 minus 3. It's going to be 252 and 0. So that instead of writing these two commands, you will be able to write the comment which you will see here. IP route 172.168.0.0.255.255.252 and 0 through gigabit 0, 0. And instead of having two rows, you will have single row 172.168.0.0 through gigabit 0, 0, like this. Then let's implement this configuration into our topology. First of all, I will delete my static rows which I have in router 1. So I'll take a look from the running configuration file about them, and here it is, only one static route I have. I'll copy it, and in global configuration mode I'll type command no space and paste it. Then I'll take a look for my routing table one more time. I don't see my static route. Now I have to provide configuration which I found of the summary route which I found here. So IP route 172.168.0.0 gigabit 0.0. Now show IP route command will show me the information about that network. Oh, did I configure it? Oh, I'm sorry, I made a mistake, so I have to improve my mistake. I'll write no. I'll just bring this command back, and I'll type the same command, but instead of placing here 255, I'll write 252 to define that my prefix is 22. Do show IP route static. So I have one network with prefix 22, as you see here. This directly connected through gigabit 0.0, but actually it's not directly connected, but as you know, it is a type of the static routing. Now let me check, is my static route, summary static route, satisfy these two networks or not. So I'll just try to make ping from PC2 to PC4. It is successful. And let me try to make ping from PC2 to PC5, which is on the different network. It is failed. Maybe I think that it's failed because of the ARP process. So let me try to make ping one more time. Alright, it's failed one more time. So then I have to investigate what's happening with this road. We can investigate it through the simulation mode. In simulation mode, we'll just take a look for ICMP and ARP packages. And let's make ping now from PC2 to PC5. Packet goes to router 1. Router 1 sends ARP request to router 2. Okay. Then we don't have reply somehow. Yeah, I think that I found the problem, guys. Sorry. So let me tell you in which step do we have problem. The problem is that router 1 knows about summary route which satisfies these two networks, but router 2 knows only about this network. So if I'll take a look for routing table of router 2 and only static routes, so then I will see only network 172.168.1.0. So that I have to write second static route, or I can use my summary route, and before it I will just delete this route, show IP no IP route, and the same 172.168.10.0 with subnet mask of prefix 24 through serial 000. yeah, it's saying that, oh, what you want to delete if we don't have such kind of network. Yes, it was my fault, and like this. And now I'll write the comment IP route to network 172.168.0.0, and as you remember, we have found with you the summary routes like this. Alright, show IP route static will show me that I have prefix 22 and I have this network, which will satisfy some route for two networks, which we see here. And let me now try to make ping from PC2 to PC4. Alright, it goes, and at the same time I'll try to make ping from PC2 to PC5. Alright, here we again can see the ARP process. Then let me delete both of these communications and I'll just try to make communication from PC2, PC2, PC5. Alright, now we see that we have communication for both networks by using the static route, which is called the summary static route, which is satisfying the both networks. And actually, when you make such kind of summary, you satisfy not only two networks, but you satisfy more combinations. So we have here combination like this and like this. So networks 172.168.0.0 with prefix 24, network 172.168.10, 172.168.20, and 172.168.30 networks with prefix 24 they will have common address like this. Okay, and in case if you have more networks, so that you can get summary again, you can make summary again, which will satisfy your static route for all of these networks. So your prefix may be decreased, okay, to increase the networks which will be in the common address. Now we know what is the summary route. It's time to take a look for the default route. And default route is the route which is most summarized route. It's written in this way, so IP route 0000. As you see, it is also summary route, and wildcard mask, the subnet mask is also all with zeros, and that you can just give this configuration to your router 3, which has connectivity to the internet. So that in internet we have a lot of networks, and it's not possible that your router in organization will know about all the networks, okay? But it is obviously known by router 3 that router 3 knows has connectivity with the internet. And when router 3 will receive the packet, for example, for a network 120.1.1.1.0, then router 1, if it has default route, it will send it to the internet. Okay, so maybe on the internet service provider side, this packet will find the way where to go. Okay, and the same thing can be configured on router 2, so that if router 2 will receive any packet with will receive the packet with any destination IP address, router 2 may say that, all right, I don't know exactly will you be successful or not. I mean, it will say to packet, but I think that router 3 will help you. And router 3 will say that I also don't know exactly where this network is placed, is located, but you can go there and you can try to be successful. And the same thing can be configured on router 1. So that in router 1, if you want to make configuration of default static route, then you type IP route, all zeros, and exit interface gigabit 0, 0. And the same thing can be configured on router 2, but with interface as 0, 0, 0. And on router 3, it's going to be interface as 0, 0, and 1. Now, let me show you how to make this configuration on the packet tracer. So we'll go to make configuration of router 3, and router 3 is, as you see, connected to the internet. From the global configuration mode, we'll type the command IP route. So let me try to do it here. IP route, and all of them of network address will be zeros, and subnet mask will be 0 too. And our exit interface is going to be S001. And if you'll take a look for your routing table, you will see in your routing table information about this network. As you see, it is S with star, whereas star is saying that approximately this is candidate for default route. Okay, statically configured default route. And when your router 3 will receive information, will receive the packet with unknown destination address from this routing table, your router will resend this packet to interface S001. And let's make configuration of router 2 with also the default static route, but the exit interface is going to be different. It's going to be S001. IP route 00000000 and exit interface. Do show IP route. So we have it. And on router 1, we'll make the same configuration, but the exit interface will be changed. IP route and gigabit 00. Sorry. Do show IP route. And now we have it. Now let's make test with you how our default route will work. We'll make ping from the in the simulation mode, ping to address which we don't have in our network, like this. Then our packet will go to router. Router will try to define the MAC address of the next hop, because the ARP cache is not working for a long time. Okay, that is why it is cleared periodically. And you see, router 1 doesn't know about network 123 to which we sent the packet, but it has the default route. After your router will not find information from the routing table, it will send the packet to default route. And the same thing happens on router 2, and router 3 resend it to internet. And you see, this is just actually the router. I just changed the icon here. It's like a simulation of the internet. And but the main thing which I want to tell you about the default route. The default route is such kind of route which is used as a backup on your router. So if your router doesn't find the destination IP address in its routing table, sorry. If your router doesn't find the destination IP address in the routing table, a router will just resend this packet to the default route. And now it's time to speak about floating static routing. Floating means that using the backups during the route, imagine that you have router 1 which is connecting to router 2 and router 3. And router 1, router 2 and router 3 may have connectivity also to router 4. And you will have such kind of connectivity. And router 4 will be connected to the network A, for example. So that you may make a static routing so that your route from router 1 to network A will go by using interface, for example, S000. But in case if something wrong will be happening with this interface or with this route, then your router will use interface S001. Oh, it is called floating static routing. So how you can make this kind of configuration? So I think that I have to a little bit change my topology. We'll have with you another router. It's going to be router 4. So I'll just place this router here, and I'll make interconnection between router 1 and oh, it say that I don't have enough ports. Maybe I have to just place here the serial port. I will turn off my router first of all, and I will place the module to the port, and then I turn on my router. And now let me try to make connectivity between router 1, R1 and router 1. And then I will make interconnection between router 1 and router 3. So let me change the name, because we'll be confused with you. It's going to be router 4 actually. Display name and its host name is also going to be router 4. And now I have to provide here the network address, which will be like this: 4110 with prefix 24, and here we'll have 5110 with prefix 24. So this router's interface will be 1, this router's interface will be 2. Here we'll have dot 1, here we'll have dot 2. And but which interfaces do we have here? S000 from router 4 connects to router 1, and S00 and gigabit 00 connects to gigabit 02 on router 3. But yeah, it will be better if we'll place our devices. Okay, we are placing them like this. So we have here a new network, and this is IP address of my router 4 S000, and here is the gigabit 1, and its IP address is going to be 1 at the end. So without losing the time, I can just open the notepad, and in notepad I will just write the comment on router 4. First of all, I will say that hostname R4, interface S000, no shutdown, IP address is going to be 4112 with subnet mask of prefix 24. And then interface gigabit 00, no shutdown, IP address is going to be 5111 with subnet mask of prefix 24. And then I have to also make configuration. This was configuration of router 4. Now I will make configuration on my router 1. And the interface is going to be S000. I think that S0, yeah, it is S000. And IP address is going to be .1, like this. And then I will configure router 3 with IP address on, oh, see, it's going to be the problem. Interface gigabit 00. And it's going to be the configurations of router 3. And IP address is going to be .2. So look guys, maybe I didn't show it before, but you can copy this configuration from Notepad or any other text editor. And in global configuration mode, you can just paste these configurations. Let's save it. And then let me take configurations of router 1 and paste it to global configuration 2. Paste. And the last thing which I want to do on router 3, I have to also turn on the interface gigabit 02. So it's gigabit 02. And in gigabit 02 interface, we'll paste these configurations like this. Now from router 4, let me try to make ping to the neighbors. Ping 4111, and I will do it from the real time to not lose the time. It's working, you see. And now let me make ping to IP address 555 and 2. It is also our neighbor waiting. And it also works. And first packet been lost here. because our ARP process, but after we know MAC address, we are able to make ping. Now router 4, I will configure my router 4 with static route to let me say to network IP route to network 172.168.0.0. It's going to be summary route, which will be connected through gigabit 00 interface. And now my router 1 will be configured with the same route. It's actually already configured with this route, so let me show you it static. It has this route, okay, and if we'll take a look for the running configuration file, show IP route, show run, sorry, and in running configuration file we'll find this route to this network, and I will just make the same configuration but through different interface. So my route to network to these two networks being through gigabit 00, but I will make configuration that if something wrong will be with this line, then my communication can go by using this way, so that I can do it by using command, the same command like this, but at the end I will not write the gigabit interface, but I will write interface S000, S000, and afterward I am able to provide here the distance, like this is just an administrative distance. Do you remember that, guys? When you are making the static configuration of your route, then administrative distance value is just only 1. And the 0 is the best value for administrative distance, 1 is the next after the best one. So that when you are making the static configuration, you are able to provide this option of the administrative distance. You are able to write here 2 or 3 or 4, but if you will write here 1, or if you will not write anything, then your router 1 will send one packet by using this way, another packet by using this way. So your router will make equal cost load balancing. But we don't want to make equal cost load balancing. We want to make the floating static routing. That is why we will place here not 1, but for example 2. So that if you'll take a look for your routing table, you will not see any changes according to this network, summarized network. But in case if you will take a look for running configuration file, in running configuration file you will see this backup to that network, okay? So that, and if something will be wrong with this port, for example port gigabit 00 will be turned off. Let me do it, interface gigabit 00, I'll write shutdown, and now I'll try to take a look for my routing table, and in my routing table I got, look, statically connected network through serial 000 network, I mean interface. But previously my route been like this through gigabit 00. So if I'll turn on my interface, and so let me fast and forward time, and let me now write the command again, do show IP route. I have to see here the same network but through gigabit 00 interface. So S001 interface will be used as the backup pass. But if you want to make, for example, equal cost load balancing between these two passes to the same network, then you have to go and take a look for your running configuration file. You will take this value. You have to copy it through the copy button. And let us paste it to the global configuration mode of our router. But before we'll paste here no. So we are deleting route, and afterward we will not write any administrative distance value, and we'll take off no. Do show run will show you that you have the same routes, you see, to this network with the same administrative distance, but through different interfaces. So now if you will if you will take a look for your routing table, in your routing table you will see that you have this network with prefix 22 that is connected through the same administrative distance by different interfaces. One is through gigabit 00, another one is through serial 00 and 0. Alright, now I think that this is the end of our static routing chapter video lesson, and I hope that this video lesson been informative for you. And in case if you have some problems or issues with understanding the subject, you may contact me directly by this email addresses. And our next video lesson will be according to dynamic routing protocols. And I think that it will be also interesting lesson. And see you again, guys.